Hello everyone. Welcome to AI Creations. Today we talk about one of the most demanding topic, that is compiler. In this video we discuss compiler, its key functions, its uses and how it works, its examples and its types. So to understand the complete knowledge of compiler, I request you to all to watch complete video till end. So let's start our video. First discuss, what is compiler? A compiler is a computer program that helps in translating the computer code from one programming language into another language. Basically, it translates the program written in the source language to the machine language. It is a software tool that translates code written in a high-level programming language into a lower-level language. It essentially acts as a translator, converting human-readable code into a form that a machine can process. Let's discuss its key functions. Translation, error detection, optimization. Now discuss the detail of key functions. Number 01, translation. The primary function of a compiler is to convert source code, written in a high-level language, like Java, C++, Python, etc., into machine code, a low-level language that the computer processor understands, or bytecode, an intermediate language that can be executed by a virtual machine. Number 2, error detection. Compilers can identify errors in the source code, such as syntax errors or type mismatches, and report them to the programmer. Number 3, optimization. Some compilers can optimize the generated code to improve its performance, making it run faster or use less memory. Let's discuss how it works. Lexical analysis. The compiler breaks down the source code into a stream of tokens, identifiers, keywords, operators, etc. Parsing. The compiler analyzes the token stream to check the syntax of the code and build an abstract syntax tree. Semantic analysis. The compiler checks the meaning and consistency of the code, such as type checking. Intermediate code generation. The compiler generates an intermediate representation of the code, which is a more machine-independent form. Code optimization. The compiler optimizes the intermediate code to improve performance. Code generation. The compiler translates the optimized intermediate code into machine code or bytecode. Let's discuss the examples of compiler. Example 1. C, C++, and Java compilers translate high-level code into machine code that can be executed directly by the computer's processor. Example 2. The Java compiler translates Java code into bytecode, which is then executed by the Java Virtual Machine (JVM). Example 3. Python, Ruby, and PHP are often interpreted languages, but some implementations also use compilers to generate bytecode. Let's discuss types of compiler. Compilers can be characterized by two ways: based on the number of passes, based on functionality. First discuss the compiler that is bases on the number of passes. Single pass compilers. These compilers process the source code in a single pass, translating it directly into machine code. They are known for their speed but may not perform extensive error checking or optimization. Two-pass compilers. These compilers divide the compilation process into two phases: front-end and back-end. The front-end analyzes the source code, and the back-end generates the machine code. Multi-pass compilers. These compilers perform multiple scans, passes, of the source code, breaking down the process into smaller, more manageable parts. This allows for more thorough error detection and optimization but can be slower. Now discuss the compiler that is based on functionality. Cross compilers. These compilers run on one platform but produce machine code for a different platform. They are useful for developing software for embedded systems or other architectures. Just-in-time compilers. These compilers translate code into machine language during program execution. They are commonly used in languages like Java and JavaScript to optimize performance by compiling code as needed. Source-to-source compilers. Transpilers. These compilers translate code from one high-level language to another. Incremental compilers. These compilers recompile only the modified parts of the source code, making the compilation process faster. Bootstrapping compilers. A bootstrapping compiler is written in the same language it is intended to compile. Often used as a starting point for compiling a language. Decompilers. These compilers do the reverse of standard compilers. They translate machine code back into a higher-level language or source code. Debug compilers. These compilers are designed to include extra information to help developers debug their code, such as line numbers and variable names. Optimizing compilers. These compilers focus on producing machine code that is efficient and performs well. Assemblers. While not technically a compiler, assemblers convert assembly language code into machine code. Interpreters. Interpreters execute code line by line without necessarily converting it to machine code first. Some of the other uses of compiler are: compiler construction. Compilers themselves can be built using compilers, which are tools that generate compilers. Security and stability. Compilers can help detect and prevent errors that could lead to security vulnerabilities or instability in software. Game development. Compiler technology is crucial for game development, as it translates game logic and actions into machine code that can be executed efficiently on different platforms. Scientific computing. Compilers are used to optimize complex scientific computations, especially in areas like high-performance computing and machine learning. Many programming languages utilize compilers to translate human-readable source code into machine executable code. Examples include C, C++, C#, Rust, Go, and Java. These languages are often categorized as compiled languages because their primary method of execution involves a compilation step. Examples of compiled languages: C and C++. These are classic examples of compiled languages, known for their performance and control over hardware. C#. C# code is typically compiled into an intermediate language, IL, which is then executed by the net runtime. Rust. Rust is a systems programming language that uses a compiler to generate highly optimized machine code. Go. Go is another compiled language, designed for building efficient and reliable systems. Java. Java code is compiled into bytecode, which is then executed by the Java Virtual Machine, JVM. Swift. Apple's Swift programming language also uses a compiler to translate source code into executable code. So this is the complete detail of compiler. I hope you all understand the complete concept of compiler. If anyone have any query related to this video, ask me in comment section. Stay tuned for next upcoming videos. Like, subscribe and share my channel for next upcoming videos and updates. Thank you.